Okay, sir, this is my project, which is the 12 volts fluoro inverter. So the components of the project is the 220-watt tube fluorescent bulb that is connected in series, the transformer, and the control circuit for the power inverter. The transformer is made up of ferrite rod and three kinds of winding, which are the primary winding, the feedback winding, and the second winding. Where we will know the certain functions of this winding for our inverter. The cycle starts by turning on the transistor via the 180 resistor, and that is connected on the base of this transistor, and this causes for the current to flow in the primary winding, which is this one. Then as the current flows in this winding, there will be a magnetic flux that is inside this transformer that is produced by the primary winding, and this passes through the ferrite rod. So the feedback winding then that is also found in the transformer is also wound around the core of the ferrite rod. So the magnetic lines that passes through that winding can also produce a voltage. Then this voltage that is from the winding and from the transistor assist together so that the transistor will turn on harder. Then as the more current that flows in the primary winding, the more the magnetic flux also increases or will have its maximum value. This causes more voltage to be produced in the feedback winding, and the transistor turns fully on. So as this turns on, the magnetic flux also is in its maximum. Even though there will be maximum magnetic flux and current in the primary winding, this will not cause for the secondary winding to produce a voltage, because the magnetic flux is in steady state. So since it is in steady state, we will not be able to transform in or step up the voltage that is from the primary winding. So what happens here is that the feedback winding helps it to have an effect of for letting the secondary winding to produce the voltage. So what happens is that since the magnetic flux from the primary voltage is stationary, so there will become a time that the feedback winding will have a zero voltage. So as this happens, the transistor is turned off in a small amount. So this will have the effect of decreasing the magnetic flux inside the transformer, because the current that flows also decreases because of the zero voltage that is not produced by the feedback winding. As this happens, the situation in the feedback winding changes, because the voltage in the feedback winding then produced in the opposite direction, and the transistor begins to turn off even more. So the magnetic flux inside the core begins to collapse very quickly, and this produces a very high reversed voltage on the base of the transistor that turns off the transistor completely. So this is how we get the positive and negative voltage of our transistor. So the collapsing magnetic flux of the transformer cuts the turns of the secondary winding, where 2.5 volts is produced per turn. So since there are 450 turns for the secondary winding, this transformer will produce, this is the secondary winding, this transformer will produce 100 volts that will strike the tube. Then it will light it, because the magnetic flux, the energy of the magnetic flux will be then converted to electrical energy that will light this tube. So this is how the inverter operates or works. So this is how a 12 volts fluoro inverter works. But if ever, however, if there will be further study for this project, it will be better if the control circuit will not be on the breadboard, but will be mounted on or plot in the PCB, so that the components will not have a disconnection, because at times this will cause the inverter for it not to work. So
if there will be a further study for it, it will be better if it will be in the PCB. Thank you.